the type of ideas I would like to publish are actually the simple ones. Like I like to think about like little pearls. There is a simple idea, and you take some kind of method and you infuse this idea into it, and then it just works better. My research field is operations research, or management science, also sometimes called. I studied computer science, but then I got interested in algorithms for operations research, and I somehow ended up here at AUB, and shifted more towards operations research, management science, decision making, but also operations management, and more business applied problems. I'm thinking about a simple idea. So let's say if you have to pack a knapsack, say you're going for a hiking trip, and you have to pack a few things, and let's suppose you put them on your bed, you have all the things, and so what do you start with? Usually you'll start with the largest things and then squeeze the smaller ones around them. And this is what we call a heuristic. I mean, it's a simple rule that allows you to reach something that is a good quality solution. If you started from the smallest and then went towards the largest, then you would end up with a bulky item at the end and no way to squeeze it in. But I mean, this rule actually generalizes. So if you take, here is, I don't know, container loading in a port, the same thing. You cannot start with the small items and leave the big one to be packed till the end. So again, I mean, and then now think about this. I can now program software that will follow this rule and actually take these items, and it can be more complicated. It can be weight, volume, other things, shapes, actual shapes. So it gets more complex, but the explanation of the basic principle, like this, start with the largest, go towards the smallest, is simple, is words. There are general methods for solving problems that just pick up ideas from nature. You should see, I mean, we have genetic algorithms or evolutionary algorithms that just have a population of solutions, like population of animals or people or something, and they do crossovers and mutations. We have ant colony optimization. We have, I don't know, bee hives, or I don't know what they call them, particle swarm, from physics. Mm-hmm. So people pick up ideas, and then they see, how does this system reach some kind of optimal or some kind of equilibrium? Can we translate it into problem-solving methods, right? Because evolution somehow gets these, individuals that are fit to nature, that they survive. Can we get somehow, all these solutions and somehow evolve them so that we find those that really fit, whatever the objective is, have the highest value of some sort. And it's being open to things that come from outside and all the experiences, or, being open. I really liked computers because they could do all these powerful things. I was at school when I first had a microcomputer, the ones that you connect to TV, and then I didn't have games. I only could program something. So I wrote in, I don't know, BASIC or some kind of other language, this multiplication table, and I felt like, this computer can just display this, calculate all these products in a split second. How long would it take me to do it? And I think then I liked drawing on screen and other things. I actually had magic before, because I was just programming whatever I felt, was interesting, or I would draw things that looked nice or something, some shapes with some mathematical functions, for example. And I would learn them like a kid, exploring, and for the fun of it. And then when I started studying, it actually lost the magic, because then they would tell me, program this, program that, and I felt like, this is like following orders. No fun in that. But then when I when I met my mentor and we started working on these problems, this is again where, you know, some of these industrial or business optimization problems are just impossible to solve in an optimal way. So then the challenge is again, you know, you need a computer to somehow crunch at least some of those, and so again the power of the computers can be used, and you know, I felt again what I felt before, you know, I can use some clever way and get this computer to do a lot of computation, but still do it in a second or a few seconds and get me something that is really good as a result. I was very lucky to have a great mentor that I met just by pure chance, and he is of course much older than I am. He had great knowledge. He has great knowledge of operations research and the field. He introduced me to many problems. The way we worked, I would write a full paper with everything I thought should be in it, and like I said, it was 2 times longer than the end result. And then I would sit with my mentor and he would edit it in front of me, which was actually useful because you know, he needed a confirmation, and sometimes he would reformulate something and I would say, but what I wanted to also say is that this is, and it's missing in this sentence. And then he would add a word somewhere and it would be there. Or, you know, it really made a difference. And also, you know, like I said, I was shocked at first that he can take this whole paragraph and then compress it to something much shorter and telling the same thing, but saying the same thing. But at the same time, it was a great lesson for me because, you know, let's say, I mean, there are a lot of constructs that you have in English that are not available in Polish. So let's say, given this and that, we prove this and that. I think it was actually, you know, because it was a very experiential learning in a sense that I wrote the first draft. I was very much attached to the ideas I wrote, and I wanted them to be there, and I understood them really well, they were fresh, and then someone could put it in so much nicer words. It was a perfect way for me to learn writing. So, and obviously he could put those ideas in much better words because he understood them also really well. So I feel like, you know, let's say if I go and hire a professional editor, when they try to rewrite my paper, they don't really understand what I'm talking about. So they will just look at words and try to reshuffle them somehow. The discipline I'm in is kind of mathematical side of business, and computers are used there also, right? So, you know, I think mathematicians value simplicity, they value brevity, right? So if you can say it in a simpler way, it's always an advantage. If you can put it in fewer words, it's always better, because anyway, concepts or ideas are difficult, and so explaining them in a simpler way makes them more accessible and easier to learn for someone who reads. So, so I think that's why, you know, we try to write in as simple a way as possible. But at the same time, like I was saying, you know, it doesn't mean it is dry and ugly or something like that. It is. I still feel, you know, like the best papers I read, I'm amazed how well written they are, you know, how pleasant to read they are. My writing has been affected very much by programming. So I learned programming actually not when I was a student, but much earlier. And actually, you know, I'm still until now accused by being too picky about things, even in a spoken language, because I always feel that, you know, things should not be ambiguous. And the same thing about writing. And of course, this is affected by my programming background, by computer coding. With computers, you cannot be vague. You cannot be more or less, about, about 5, 6. It has to be 5 or 6, and everything has to be precise, and then you have to predict every possible evolution of, some kind of processing, and then have and cover all the possibilities. So in a sense, when I write, it's the same thing. I'm thinking, have I said everything? Is there any special case that my writing, when someone reads and thinks about this special case, they will not understand what happens when this special case occurs, because I have not mentioned something. Programming affects the way I write. I think it also affects the way I think and the way I read things and look at things. So when I review a paper, again, I always think, is this explanation covering all the possibilities? Maybe there is one typical case for the policy on support for research, but maybe there are several rare cases, and if you can write it such that it's clear for the rare cases too, why not, right? And it's not more complicated for the typical cases. Yeah, it is a little bit like that. Obviously, programming is creative. I don't think programming languages are that much different from human languages. They don't carry that much emotion, but they do carry a lot of meaning. So once I just found a paper that was solving a problem. That was a problem on robotic assembly line, basically how you schedule the robots to pick up parts and install them on some boards, electronic components. And I found that, I read the paper and I felt this problem is really simple. I can solve it in a much simpler way. And I solved it, something that is standard tool in our field. It's mathematical programming, or mixed integer linear programming. And basically you write a model, and my model was quite simple, just a few lines. And when I wrote a paper, it was something like 6 pages. Later, after review, actually, I beefed it up to 8 pages. But the thing is that the reviewers were saying, this is too short, this should be just one section of a paper or a small chapter in a book or something like this. But the editor supported the publication because he said this, he recognized this has value. Is it necessary for a paper to be long to be of value? Or, I felt if it's simpler, if it's shorter, it's better. I really like writing research papers when it's something, when it's a beautiful idea that I want to communicate to maybe 20 people in the world who can understand it. I like to write about it. And it also is because, the type of ideas I would like to publish are actually the simple ones, I like to think about like little pearls. There is a simple idea, and you take some kind of method and you infuse this idea into it, and then it just works better. We start from the last thing. I test the idea experimentally if it really gives good results. So I work with coding and some data sets that either I generate or someone has generated that are realistic or someone has collected from actual industrial business problems. And then, but throughout my work, I'm thinking, what am I going to write exactly, and what will be the story that I want to tell, and then sometimes, I keep it a little bit vague, because depending on the results I get, maybe I want to talk more about this or that, or sometimes it's just too complex for me to figure out the details. Actually, the last paper I'm about to submit, I couldn't, especially in terms of computational experiments, we ended up with something like 8 tables, very large tables of results, and I had to think, because there were several stories I wanted to tell to kind of justify the way we do things, the way we solve this problem. You have to say about this and that and something else, and I had to, so I actually ended up writing by hand, what's the story? Story number 1, this. Story number 2, this. Story number 3, this. Okay, now how do I tell them without too much repetition, too many tables, too much text, because again, I want to keep it short and to the point, and then if there are, I don't know, the same table is needed twice, then I just decide which story I say first, and then in the second one I refer, or things like that. I keep notes, like these mathematical models I mentioned to you. Sometimes I will write them because they are short, and yet sometimes you write 6, 7, or 8 lines, and it's very difficult to see that you have covered every possibility in a sense. So writing them down in mathematical formats, that's what I would do. But mainly I would keep maybe to-do lists, what do I need to check, or maybe some preliminary results, like I checked this and it's horrible, I checked this and it works great, and something like that. So it's more of a notes of work in progress. It's not a big plan that I would write, and I think a lot of it happens. You remember, and obviously it would be harder if I have to do something over a long period of time. So actually I like to concentrate for a short time, work on something very intensively, and then write the paper immediately if there is something good to write about. I mean, if I do programming, see, the thing is that it's much more flexible in a sense that I keep, if I change something radically, I just keep an old version. Quite often you just want to compare the new version with the old. So let's say, think about it like an algorithm. You can enclose it and call it a procedure. Procedure, I don't know, method 1, procedure method 2, method 3. And with it's like taking notes, really. You have freedom. You can put more notes, save more notes, discard. If you really think something is useless, you can throw it away, but you can just keep notes that are not very useful, but you might find them useful in the future. Then you can just keep them. The same thing about coding. I mean, with programs, I can just write and leave everything, never delete. With research papers, this is again, if you like for research papers, I never use Word or any of those Office applications that, I mean, rarely I use them, because it's much easier to write in something like LaTeX. I feel about myself as this generation of people who were exposed early enough to computers, and I don't like books on paper. I prefer to have them on a tablet and read them because they are so much easier to move and flip and search, and I can have a dictionary in them and so on. Same thing about notes. I only use paper when it is really giving me an advantage. So with mathematical models, I can write them much faster with a pen and paper or pencil, because there is a lot of correcting usually, and with everything else, it's equally easy to write them on computers, and then I can save them and never lose them, or share them easily, right? Now with mathematical models, so whatever notes I write, I often, at the end of the project, I will take pictures, put it in a PDF file, 7 pages of photographs of my notes, and save it this way and throw away the paper, so that it's there, in the future if I ever need to look at them. When it comes to reviewing papers or reading student work, they are surprisingly similar, and quite often really poor quality. I mean, I'm not an expert writer, and like I said, I learned just by doing it and reading other people's work. So I'm talking about research writing, and then so first of all, I want to say I have a lot of understanding when people write poorly, because I mean, I don't think I write that well, first of all, and I know not long ago I was writing horribly. So, so I have a lot of understanding, but again, I mean, you cannot have too much tolerance for it, because, especially when it's a research paper, somewhere in a good journal, you know, it has to be clear. And if there is enough mistakes, you know, you lose the, you don't understand what the author really wants to say, or you're guessing too many things, and you're probably wrong about some of them at least. So, so while I, you know, kind of have understanding, I cannot tolerate it, and the same thing with students. I mean, when they submit some projects, actually, this is the difficulty, that I don't know how to help them, except to tell them things like, you know, if you can't say it simple enough, you really don't understand it. I usually struggle with, yeah, the writing of the students, because right, I feel that they are not writing about the right things, the important things, and then they write about unimportant things. I know I can tell when it's good, but when it's bad, and I need the writer in front of me and the discussion, and then maybe I can suggest something. But just to know immediately how one can correct paper is quite often not easy.